Hello everyone. Now we'll be starting with SOP and POS. And if you have watched the previous video, the video before this, where I was explaining what is needed for POS and SOP, and we got to the what you call truth table, right? So mostly these are used to solve truth table, and in most cases you are not given a boolean expression or a logic diagram, and you're only given a truth table. So how do we get that data from the truth table? And that is where we have our POS and SOP, right? Okay, so let's start with a simple example, or the example I showed you in the previous video, and then I'll show you what is POS and what is SOP. So if I remember correctly, in the previous video we had three inputs, right, and one output. So we had 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Right. Then we had, I think it was 1, 0, 1, 0, 0, 0, 1, 1. So this was the truth table. And okay, now, how do we uh, show this truth table, or how do we get our Boolean expression using through this through using this truth table via SOP and POS? Okay, so first one I'll start with is SOP, which we call sum of products, right? So sum of products meaning, for example, let's say you have the equation Z, which is the sum of products. So that means you have A times B times C plus A times B times C naught plus A times B complement C plus A complement B complement C complement, right? So this is sum of products. So you're adding multiplication. So you're adding products, right? So that's why we call it sum of products. And most of the time we work with sum of products, right? And also another thing in this SOP and POS both, that the complement line, or that was C bar or not, it's all above only one variable every time. So as you can see in this example here, they are not touching each other, right? So again, a reminder, if you watched the De Morgan's theorem, this is not equal to A, B, C complement, right? So if you haven't watched the De Morgan's theorem video, of maybe not in class, or you weren't in class, so yeah, you can watch that. That will clear out this. Okay, right? So that's one of the properties of SOP. Second property of SOP is this SOP indicates all the output that is 1, or you can say high. Right. So SOP is only for the output that is 1. So um, we can say it's for this one, this one, this, and this. Right. So SOP only indicates where the output is high or 1. Right. Secondly, uh, in SOP, mm, we also have, let's say, for example, if we take a variable a, right? So if it's a is like this, so that will be 1, and if it's a complement, that will be 0. Similarly, if it's b, that is on b complement, that is 0. And same goes for c is 1, and c complement is 0. Right. And remember this, because we'll be working with, and I'll show you why we do this, right? And also, this form of equation, as you see, mm, uh, but I'll show you now. Okay, so maybe let's just start with this example. So we have this, right? So we want the SOP form for y, right? Y in, so the way the question is, uh, or the way the question is given or asked, is maybe give the, you can say, the standard SOP form of y. Or another way to ask the question is give the chronological or canonical, canonical SOP form of y. Right. So I'm just introducing this terminology canonical because it's used a lot sometimes in the exams. So yeah. So if you know it, that is good, right? So the question is either give the standard form of the SOP or the canonical form of the Y. Right. So both of them, they are the same thing. Standard and canonical doesn't matter. It's the same thing, right? So how do we express this? So we'll express this Y in form of like this. So how do we do it? So let's say now we have Y, right? Now we check where is 1. So 1 is on the first, where A is 0, right? And we said when A is 0, so that will be a complement, right? Now we check what is B. B is also 0, so B complement. What is C? C is also 0, so C complement, right? So we are just checking that. Now we add. Now we go to the next one. Now we check here. This one where A is 0, so we'll have A complement. Where B is 1, so we'll have B. Where C is 0, so that will be C complement, right? Plus, now we check where is 1. Okay, 1 is here again. Now we check this. A is 1, so we put just A, because we said when A is equal to 1, it's A. B is 1, so we put B because B equals 1. And then we said C is 0. So when C is 0, we say C complement, right? Plus, again, we check this last one where A, B, and C, everything is 1. So that will be A, B, and C, right? So as you can see, this is what we call, so this equation, we call it standard SOP, not R, SOP form, or you can say canonical SOP form, right? Right, so this was your canonical SOP form, correct? Now, there's another form in which they give you an expression, and that is related to the numbers. So to show that, so let's just write the numbers on the side, right? So this will help you. So this is 0, 1, 2, 3, 4, 5, 6, right? And how do we express this? So we can also express y in a form of its y, then sum of, then we say wherever you see 1, so 1 is at 0, 1 is at 2, 1 is at 6, and 1 is at 7. So we write that in numerical order, so 0, 2, 6, and 7, right? So this equation can also be expressed like this. And this form, we call it, this is called mean terms, right? So we call this mean terms. So whenever they ask you mean terms, they want you to express it in this form. And also these values are also asked mean terms, right? And sum of the, so even these values, this one, or what do you call, a simple expression, or the term we call the mean terms, right? And how do we get that? So that's the easier way. Another way to get these values 0 to 6, 7 is you say, okay, it's A complement, so we know it's 0. That is B complement, we know that is 0. That is C complement, that is 0, right? So that in binary is 0, and in digit it's going to be 0, right? Now we have, again, if we come to this term, A complement times B times C complement, we can say A complement is 0, B is 1, C complement is 0, and that will be 2, right? And we do the same. We say, okay, A is 1, B is 1, C complement is 0, and that is 6. And all of them here is 1, 1, 1, so that is 7. And that comes to our mean term, right? So this is your SOP. Now, I have a standard example for SOP, correct? Now we go to our POS, or we say product of sum, sums, right? And then it works the similar as product of sum. So in this case, let's say for example we have X, right? And this can be expressed in a form of like this. You have A plus B plus C multiplied by A plus B complement plus C multiplied by A plus B plus C complement multiplied by A complement plus B complement plus C complement, right? So this is, as you can see, we have our sum first, then it's multiplied. So this is product of sums, right? And this we call a, you can say a standard POS form. Right. So this is standard POS form. Or you can say it's a standard canonical POS form, or you can say canonical POS form. Right. So in POS, it's remember it much easier way. Just remember POS is opposite of SOP. So POS is opposite of SOP, meaning POS is used to indicate all the zeros or low in the truth table, right? So POS is used to indicate all the zeros in the truth table, right? And in POS as well now, where we had our input values A, B, and C. So in POS, A is 0 and A complement is 1, right? Similarly, B is 0 and B complement is 1, and C is 0, C complement is 1, right? So as I said, if you remember SOP, then you remember in POS everything is opposite, right? Now, now we are going to represent the this truth table using POS, right? But then we'll be only representing all the zeros, right? So we start with Y again. So we start with the first 0. So we see, if you check, the first 0 is here, where our A is 0, B is 0, and C is 1, right? So in this case, our A plus B plus C complement, right? So because we said our first 0 is where A is 0, B is 0 and C is 1. Now we go to our second 0, which is at number 3, which is where A is 0, B is 1, C is 1, right? So where A is 0, B is 1 and C is 1 as well. Right. We were, as you can see, correct. Now we check our third 0, which is where A is 1, B is 0, C is 0. So now we'll do that. So A is 1, B is 0, and C is 0, right? Now our fourth 0, or our fifth or third 0. Yeah, fourth 0, which is at 5, where A is 1, B is 0, C is 1, right? So this will be A is 1, B 0, C is 1. Okay, so as you can see, this is again our standard POS, or you can say again canonical POS, right? Form. Okay, and then we call this, so remember these terms are called max terms, right? And now we can write this in terms of max terms. Now this one, here we use the pi symbol, right? And we write all the values where zeros has been present. So for example, here where A is 0, B is 0, C is 1, so this will be what, 1? So we put 1, where A is 0, B is 1, C is 1, this is 3, okay, so we put 3, right? Now let's say we have uh, A is, in this case, will be 1, B is 0, C is 0, so that is 4. So we put 4, and then we have 1, 0, 1, which is 5. So we put 5 here. Right. So this becomes our max terms. Right. So what to remember in this case? You should remember this terminology, max term and canonical form or standard form, as well as these conditions here. How a complement is different from SOP. So remembering this part here. Right, you don't have to remember what does SOP stands for, what does POS stands for. That is almost never asked. So right. So if you remember this and this part as well. So this is a POS is used to indicate all the zeros, and SOP is used to indicate all the output that is 1, and POS is used to indicate all the, okay, let me add all the output that is, so here all the output that is zeros or low in the truth table, right? So yeah, okay, okay. Now let's try another example, yeah, another way also, right? Okay, let's try another example. In some cases also, what is done is, let's say you're you're given an equation, maybe for now, yeah, f, right, with a, b, and c. Okay, and then it's given some, then you are given 0, maybe some SOP, and then you are given the SOP from something like this: 0, 4, 6, 7, right? And as you can see, it's in numerical order, right? So if you are given a SOP form like this, so you can say at all these values, so this is your mean term, and at all these values your, and then at these values, or at 0, 4, 6, 7, your output is 1, right? So if that the output is 1, that means the rest output is 0, right? So we can say at 0, 4, 6, and 7, the your output is 1 and the rest output is 0, right? So in some cases you are given so, and you can say this is the mean term, so right, so we want the um, so the questions from here can be give the standard SOP form, or you can say even again chronological form, or in bracket canonical SOP form, right? So that could be the first question. So how are we going to do that? Again, we have 3 inputs, so first thing we do, we need remember a is 1, a complement is 0. So first thing we must remember, a is 1, a complement is 0. Same goes with b is 1, b complement is 0. C is 1, C complement is 0. Now we can express this in standard form or canonical form. So 1 is at 0, 0, so that will be 0, 0. So A is 0, B is 0, C is 0, right? 4. 4 in binary is, so, okay, let me not confuse. So what we can do is, we can start with this. Easier way to do it is, to get the standard form is, we just write that number 0 in binary, 0, 0. plus 4 in binary plus 6 in binary and 7, right? Now underneath each we write the letter. So when it's 0, that is A complement, B complement, C complement plus A, B complement, C complement plus that will be A, B, C complement, and everything A is, there's no complement right here, plus B. So now this becomes our standard form, right? Similarly, if you if you have the SOP, you can get the POS, right? So how does that work? So we know we have our SOP numbers or our mean terms, which is 0, 4, 6, and 7, right? So if our ones are 0, 4, 6, and 7, so the remaining numbers must be the zeros, right? So our max terms will be what? So we have 0 there, so we'll have 1, 2, 3, and 5. Right, so the numbers that are missing here will be your POS. So this is our max terms, right? And using that, we can get our standard SOP form or canonical SOP form. So again, we do the same. To make it easier, we write 1 in binary, 2 in binary, 3 in binary, and 5 in binary. Right, and remember in POS we have everything opposite of SOP. So POS A is 0, A complement is 1, B is 0, B complement is 1, C is 0, C complement, C complement is 1, right? So our equation will be something like this. So A is 0A plus B0B plus C complement. Similarly, we'll have A plus B complement plus C, right? Similarly, in this case, A is 0 plus C, B complement plus C complement, because both of them are 1, right? So in this case, A is 1, so A complement plus B plus C complement, right? And maybe you might have a question as well, so, but before I go to that. So this is a standard SOP, POS form. So we can say this is standard POS form, the canonical POS form, right? Or one of those. So some of you might ask, why am I using always A? So most cases, when you, if they don't mention it, so if it's like this, you input alphabetically, so A will always be your MSB, and then C will be your LSB, right, in most cases. So that is how we do it, right? Or you can have four inputs. So you have, let's say, A, four inputs. Maybe you can have different four inputs. Let's say you can have uh, W, X, Y, Z, right? Then your output function F, right? You have four inputs, so your W will be your MSB, your Z will be your LSB, right? That is how we work most of the time, right? And that is how we will put those values in when we express the standard form or the canonical form, right? And if we want to now express the truth table of this Boolean equation, what we can do is we have both SOP and POS forms. So we can say we have our A, B, C, and function F. Alright. Then we can have 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right, so now to check where we have 1 and where we have 0. Right, so we said, let's just go there. We said we have 1 at 4, at 0, 4, 6, and 7. So we have 1 at 0, 4, 6, 7. Right. Okay. And then the rest will be 0, 0, 0, and 0. Right. And so as you can see, this is your SOP, which is quite easy to work with and understand, right? Over time, you just need to practice. And as well here at POS, we can say this in binary is 1, this in binary is 2, this in binary is 3, and this is 5, right? Now the question might be, okay. Now the question might be, how do we get the logic diagram, right? To get the logic diagram, mostly we use the SOP form. So we'll use our SOP equation, or SOP standard form, which was A, B, C naught plus A, B, C naught, B, and C naught plus A, B, C, right? And to get our maybe logic diagram from this, we can simplify this equation, right, using Boolean expression. So what we can do is, let's say in this case, if we check these two equations, we can take out a common factor here, or not the common, our common factor here will be B complement and C complement plus A complement plus A, right? And similarly, we can do this here as well. So we can take out AB and we'll be left with C complement plus C. And if you remember, I'm not sure which rule it is, but A complement plus A is 1. Right. So that becomes AC plus AB. And then you can write this in alphabetical order to make it easier. Right. And then simplified SOP form. Now we can get our Boolean logic diagram, right? Using this. Okay. So this is one of the examples. And you also get maybe a truth table with two inputs. For example, let's say you have A, B, C, right? Then no, sorry, with it again with three inputs but two outputs, X and Y, right? So 0 0 0 0 0 1 0 1 0 1. Sorry, that will be 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Right. And then you can have two outputs, maybe like this 0 0 0 1 1 1 0 0, or you can have 0 1 0 0 1 0 0 1 1. Right. So, but and it might look confusing, but still you treat them. Okay, 0 is here. Still you treat them individually, right? So again, you solve the problem individually. So here we have a 0. So we have 0 and 0, right? So again, you still treat them individually. So if we want a SOP for X, or not SOP, let's just say again write in full. Alright, it's canonical, canonical SOP form for X. So that will be, so I'll just write X, then where X is 1, I'll write those values, right? So X is 1 here, where A again. So SOP, remember, where A is 1, A complement is 0, B is 1, B complement is 0, and C is 1, C complement is 0. So our SOP form for X will be, the output X is 1. So at A complement BC plus A B complement C complement plus A complement B complement C complement, right? And let's just say this canonical POS form for Y and the max terms, right? So canonical POS form for Y will be everywhere where there is zeros, right? And again, remember with POS, a complement, okay, with POS, A is 0, A complement is 1, B is 0, B complement is 1, and C is 0, C complement is 1, right? So Y will be where it's 0, so that will be A plus B complement plus C times A plus B complement plus C complement, right? Hmm. I think I might have confused something. Okay. Add this first one here. Yeah. I might have made a mistake, so sorry for that. So, okay. Let's just go back for X. Where X is 1 is so A, then B complement C. Yeah. So that is correct. So now we can move to Y, which is A, B complement C. Now again at 3, which is 0 is A, right? B complement, C complement. Then if we check Y is 0 here, so it will be A complement plus B plus C complement, right? And then we have our this one, where at the end everything is A complement plus B complement plus C complement, right? And then we said we need to have the max terms as well, right? So this is going to be our max terms. Y pi equals, then we just write the number where y is 0, which is at 2, 3, 5, and 7, right? So that is max terms, and that is your canonical POS form, right? And then the last part, you might be asked something like this as well. Let's say, for example, now you are given a Boolean expression. Maybe we can say, yeah, let's just say f equals, and let's use some other variable. Maybe f equals w x y plus w x complement plus w uh, plus maybe x plus y complement, right? So this is the equation given to us, right? Mm. So this is the equation given to us, and now we want to, they say, express this in canonical SOP form or standard SOP form. How are we going to do this now? So one way to do it, it's a bit longer way, is to do the truth table for this Boolean expression. a bit long, but easy to do. Right. So you have your 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right. So one method is to get you using Boolean expression, right? Or the truth table. So you use this, you substitute the values in the truth table to get the values correct. Or another way is to another way to do it is another way to do is you have some uh, you have your w, x, and y. So that is all the terms, right? So we have uh, four terms here, right? And then okay, so we check here w, x, x complement, right? So if we check in this term, which term is missing? Here, if you check, we are missing which term? Y plus y complement, right? Because if you remember this law again, a plus a complement is 1. So we had a common factor here, correct? Y plus y complement. So we will have two terms here, so that will be w times x complement times y, w times x complement times y complement, right? And then we have another term here. We have x and y, so we are missing which value is here? W, right? So we are missing w plus w complement. So always remember, if you are missing a term, it's always that term and its complement. So this will be wx y complement, or then we have w complement and xy complement, right? So by using this, we got our form, so we can have our standard form, something like this. So we can say our canonical or SOP form for f will be wxy plus wxy w times y complement times x complement times y, okay, plus wxy complement plus w complement x times y complement. So this is your standard SOP, right? So we can do it something like this as a. Let's try another example, and then mm, before we try, then using this, you can get your. So using this, you can get the mean terms, your standard POS form, or your canonical POS form, and your max terms, right? And maybe another example could be uh, you're given again f equals a times b times c. Then you're given ab complement plus c complement, right? So how are we going to do this? Again, we have a and b, so one variable is missing, which is c. So we will have here c complement plus c, right? And that will give us a, b, c, and that a and a, b, b complement times c complement. Now we have c here. So we are missing two variables, which is going to be a plus a complement plus b plus b complement, right? And then sometimes what we can have, maybe let's just do this. So maybe if we multiply this, we will get something like this as well: a complement b complement c complement. So you see they are repeating, right? So if they are repeating, you just keep one, so you don't have to include both, so you just keep one, right? Okay. So what we can do is, maybe easier way to do this is you get a, and then the other one will be a complement b complement, right? And we'll put that in alphabetical order, so it will be a b c complement, a b complement c complement, right? And this will be a complement a complement b, then c complement, and then we'll have a complement b complement c, right? And as you can see, these two are repeating, so we only keep one. So our final answer will be a b complement c plus a b complement c complement plus uh, this and this, they are the same, right? A b c complement plus a complement b c complement plus a complement b complement c complement, right? Then again, you wire this. So again, this is a standard SOP, form canonical SOP form. And then using this, you will get your standard POS, standard POS, uh, your max terms after the POS, as well as you can get your mean terms, right? And I would recommend when even if they ask you POS first, maybe do SOP first, then it's easier to work everything out once you have your standard SOP form or canonical SOP form. Right, okay. Then I think we are done with SOP. Yep, no, thanks.